Welcome to your deep dive into internal energy, specification point for point 3.3 for AQA GCSE Physics. This topic is crucial because it explains what happens to substances at the particle level when we heat them. Examiners love to test your ability to distinguish between temperature and energy, and to apply the correct formulas for different scenarios. By mastering this guide, you'll confidently tackle calculation and explanation questions, linking directly to the particle model of matter and energy changes. Let's break down internal energy. Every substance contains particles that move and interact. The internal energy is the total energy stored in these particles. It has two parts: kinetic energy from particle motion, which relates to temperature, and potential energy from the forces between particles. When a substance changes state, particles move apart, increasing potential energy without changing temperature. Now for the essential formulas. When a substance changes temperature, we use the specific heat capacity equation: energy equals mass times specific heat capacity times change in temperature. During a state change, temperature stays constant, so we use specific latent heat: energy equals mass times latent heat. Remember, latent heat diffusion is for melting or freezing, and vaporization for boiling or condensing. A heating curve shows how temperature changes over time when a substance is heated. Initially, the solid's temperature rises as particles vibrate faster. At the melting point, a plateau appears. Energy is used to overcome forces between particles, increasing potential energy but not temperature. The same happens during boiling. Understanding these plateaus is key to avoiding mark-losing mistakes. Let's work through a typical 6-mark calculation. To find the total energy to turn ice at 0 degrees Celsius into water at 20 degrees Celsius, we need 2 steps. First, the energy to melt the ice using the latent heat of fusion: 2 kilograms times 334,000 joules per kilogram gives 668,000 joules. Second, the energy to raise the temperature of the resulting water: 2 kilograms times 4,200 times 20 gives 168,000 joules. Adding them gives 836,000 joules. Always check your units and state the final answer clearly to secure all marks. Common mistakes cost marks. First, many students confuse temperature with energy. Temperature is just the average kinetic energy, while internal energy is the total. Second, always pick the right equation. If the substance changes temperature, use specific heat capacity. If it changes state with no temperature change, use latent heat. Finally, don't forget units and always write down your working. Examiners reward clear, logical steps. To wrap up, internal energy is the total particle energy, combining kinetic and potential stores. Temperature reflects only the average kinetic energy. For calculations, use the specific heat capacity formula when temperature changes, and the latent heat formula during state changes. On a heating curve, remember that plateaus mean constant temperature. Energy is going into potential energy, not raising temperature. Master these concepts and you'll secure top marks in your AQA GCSE Physics exam.